take a look at what are called compound triangles and also some right angle word problems. Okay, so compound triangles are triangles where there are multiple triangles within one picture, as you can see here. Okay, and then sometimes you'll be asked to solve for one specific thing, like either an angle or solve for a side length, or I could say solve the entire thing, in which case you'd want to solve for this and each of the side lengths. Okay, so that's what's going on with compound triangles. Okay, so some of the success criteria associated with that will be using trig ratios, Pythagorean theorem to find missing information. Okay, and you can use, what's interesting about the compound triangles is there's other information provided in the question that you can use in order to actually answer your question. Okay, that's what's kind of cool, right? And so that has endless real world applications, because sometimes you can actually figure something out in real life that isn't maybe in your picture, but you can use it, okay, to help you solve the problem, right? That would be like a compound triangle, right? And so the other thing we're going to do today is solving word problems involving right angle triangles, okay? And then the key to that, and the key to any word problem really, is can you correctly represent the problem using a diagram, okay? So that's going to be the emphasis for that particular part, okay? And I'll do this with this lesson in 2 videos. Part 1 will be the compound triangles, and part 2 will be the word problem, okay? So let's take a look at these 2 compound triangles, okay? So in the first one, the first thing I want to do, okay, is take a look at triangle ABC. Okay, so that's going to be the big one, A, B, C. Okay. Okay. And then so what I can do here is I want to be able to find side length A. Okay. And if you remember how in the last lesson we labeled triangles, right? I'll get rid of those. This was little a, this was little b, and this over here would be little c. That'd be the whole side length. So little c in this case would be c would be equal to AB, side length AB. Okay. It'd be side length AB, right? Which is going to be the 6 plus 9, which is going to be 15. Okay. So find side A. Okay. If we find side A, then I now know 2 side lengths, and I can use a trig ratio to find the angle. Okay. And then the question will be over. Okay. So let's find side length A then. Okay. So let's I see here, okay, if we ignore the fact that this is here for a minute, okay, I'm going to try and do my best to get rid of this for you. This doesn't exist, the red highlight, okay? We just got this triangle, and C is going to be 15, right? That came from that. So what you can do is I know the hypotenuse, I know that side length, I can use this. So to find that, I can use Pythagorean theorem. Right? And so I can go a squared plus b squared is equal to c squared. And so a squared is going to be, actually, it's using the exact letters, so that's nice. So a squared is what I don't know, plus b squared. In this question, okay, this triangle isn't labeled too well because the hypotenuse always has to be on the other side, right? So what you can do is 15 squared is equal to, remember C is always the hypotenuse, okay, so it's got to be 25 squared. If you flip those, you're going to get a negative number, and then you're going to get it wrong. Okay, well, you're not even going to get an answer because you're going to try and take the square root of a negative number. That doesn't work, so you can't do that. Okay, so a squared is equal to 25 squared minus 15 squared. So a squared is equal to, we can go to our calculator here, okay, 25 times 25, 625 minus 15 is 225. Okay, so a squared is going to equal 625 minus 225 is 400. Okay, and a is equal to the square root of 400. Okay, so a is going to equal 20. Okay, so once you have that, now you can actually go on here, get rid of that, say, okay, this is 20 centimeters. Okay, and now you can go in the second step here. We can take a look at in triangle BCD. So that's this one now. So we're going to change what we're ignoring. So we're going to ignore this stuff now, right? I'm only looking at the triangle B, C, and D, okay? So in triangle BCD, I can now find theta, okay? And to do that, I'm standing at theta here, okay? Standing in this corner. I'm going to look across, and I see that the opposite is 15, okay? So opposite equals 15, and that, if I'm standing at that angle theta, then adjacent is going to equal 20. And if I recall, so katoa, okay, I have opposite and I have adjacent, so that looks like tangent. Okay, so I'm just going to do tan of the angle is opposite over adjacent, which is then therefore going to be opposite is 15 divided by 20. This is tan theta. Okay, and then tan theta, I'm just going to get a decimal for these two. So 15 over 20 should be 0.75. Okay, 0.75. And then what you can do is you have to go, I'm going to get rid of the SOHCAHTOA down here. Okay, you go to your calculator. Remember hitting so I have a decimal, and I need it to come out as a whole number, obviously, for an angle. And so to do that, I have to hit the tan inverse key, which isn't here, okay? You remember I have to go hit the shift. That changes it to the tan inverse, okay? And then you can click tan inverse of that angle, and there you go, or that decimal, sorry, ratio. And you get 36.86, so which we can call 37 degrees, okay? Oh, but here's the problem. I did something that you guys maybe would have done too, so it's good that I did this, okay? Here's the issue. Is that side length 15? By that I mean, is the opposite 15? Remember, everything I highlighted in red, I'm not going to use, right? So that 6 isn't there. So actually, the opposite is going to be 9, right? Okay, so be careful with these compound angles, because sometimes, or compound triangles, right? Because sometimes you're provided information to help you in the first stage that might actually be detrimental in the second stage, right? We would have gotten the wrong answer here, right? But if I go 9 divided by 20, 0.45, then I can take the tan inverse. That's better, okay? So one sec here, 9 divided by 20, I think. Let's just do that again. 20, okay, 0.45. And then so therefore theta, you gotta take tan inverse of that. And so theta is equal to 24.2 or 24 degrees. Okay, and that answers this question. Solve for theta. Now, be careful with this. This caught me too, okay?